We're going to be doing proofs, but on a very, very minor scale. They're going to be one-step proofs. I'm going to show you a picture. I'm going to show you a picture, and you're going to tell me if the lines are parallel or not, and why. So it's not like a statement, reason like we've seen before. It's just tell me, and then defend your answer. So on day one, what we learned last time was how to identify the angle relationships, and then if the lines are parallel, we then could solve, right? So that's what we learned last time. Previously, we knew if the lines were parallel, then we could use special angle measurement relationships to solve. Today we're going to be learning about the converse of that. What if I know that the angle pairs have a measure relationship first, and then I use that to prove the lines are parallel? That's what we're focusing on today. So if both the directions are true, what do we call this kind of situation if both directions are true? Do you guys remember? It's a biconditional. So when we're working with angle relationships in parallel lines, it's actually a biconditional, works both ways. We're going to be focusing on this one today, because we've already talked about the other direction. So we're going to start by looking at the angles first, and then determining if the lines are parallel or not. So if I spot in my picture here that we're going to talk about, if I see corresponding angles, what better be going on in order to prove that the lines are parallel? They should be congruent. When you guys are looking at the diagram, if you notice you have corresponding angles, if they're congruent, then you can conclude that the lines are parallel. What if you see alternate angles, whether they're interior or exterior? They should also be congruent. Sorry for the reading writing. That's an R. So if you guys see either corresponding or alternate angles, they better be congruent before you conclude that the lines are parallel. What about consecutive? Supplementary. Supplementary. Alright, so your consecutive angle should be supplementary. So it's just going to look at pictures like this. You have your generic diagram, take a look at what kind of angle pairs you have, and then decide if they're parallel or not based on the relationship. Now this little asterisk is very important, right? If you guys see vertical angles or linear pair, neither of those are going to be enough to prove the lines are parallel. And now it won't let me scroll. If you guys see vertical or linear pair, you're not going to say yes, and you're not going to say no. Because it's very possible that the lines are parallel, you just don't know. They haven't given you enough information. So for that one, you're going to choose this option right here. NEI stands for not enough information. So if you guys notice that you have vertical or linear pair, that's your option you're going to choose. You're not going to choose no. So you don't disprove that the lines are parallel, you just don't have enough information. Okay? So we're going to, if I can figure out how to get my, there we go. We're going to take a look at these diagrams. The first thing you're going to do is figure out what kind of angles do you have. What do you notice about these diagrams and how the lines are labeled? Do you see any of the little arrows? So we don't know if the lines are parallel right now. We're trying to figure that out based on the angles. So what type of angles do I have here? I have consecutive interior. Now, in order for the lines to be parallel, what should be happening with their measures? Okay, they should be supplementary. So take a look. What happens with 131 and 49 if you add them? You get 180. So, can I conclude that these lines are parallel? Yes. So you would say yes, whatever your answer choice is. Then you have to defend your answer. You have to defend your answer, and this is how you're going to do it. It's just like in a proof. If you want to say yes, lines are parallel, you're going to state a theorem that would prove that that is true. Now it's not complicated. Which angles did I use? So you're going to say consecutive, interior, angles, theorem. Whatever angles you use, you just name them and then stick the word theorem on it. Basically all this, right? But then in parentheses or off to the side, I want you guys all to write the word converse. And I'll explain why in a second, but make sure you include that. See, consecutive interior angles theorem, converse. Now when we learned on day one, when we actually learned the consecutive interior angles theorem, it stated if the lines are parallel, then consecutive interior angles are supplementary. What's going on here? We have, if the consecutive interior angles are supplementary, then the lines are parallel. So you have to state that it's the converse that we're using. And when we get deeper into proofs, you guys do need to keep that straight. Am I using the theorem or the converse of the theorem when you guys are giving the justification for that step? So if you're starting with angles and going to lines being parallel, that's the converse. So make sure you keep that in the back of your mind. All right, what relationship do I have here? Type of angles. Not their measures, the type. I heard you say.
Linear pair.
They're a linear pair. All right, this is a linear pair. Is linear pair enough to prove that they're parallel? No. Do you guys know why it's not enough? Yeah, it doesn't give you information on this line. All right, so we can't really compare anything. So you guys are going to choose any I and then just say linear pair is not sufficient. Or enough, whatever word you want to use. Whether you want to sound fancy or not. Linear pair is not sufficient. All right, what about the next set? What kind of angles are those? Consecutive. Okay. What should be going on with the consecutive exterior angles if I want the lines to be parallel? Okay, when you take 128 and add 62, what do you get? Is that what it's supposed to be for them to be parallel? So are these lines parallel? You would say no. Now, the defense for no is not going to be referencing a theorem. It's just going to explain to me that the situation is not working out. So you just say, excuse me, consecutive exterior are not, in all caps, supplement. You do not have to state a theorem because a theorem is only affirming whether they are parallel. So if you notice that they are not parallel, just explain to me what went wrong. Consecutive exterior are not supplementary. Is everybody with me on the first three? You have one example of each so far. All right, what about the next one? Which type of angles are those? They're alternate exterior. What should be true about alternate exterior angles for the lines to be parallel? They should be equal. Are they? Yes, they're both 90. Okay? So would these two lines be parallel? Yes. Now, which theorem would I state? And how would I write it? Exterior. That's what I got. Alternate exterior angles theorem. But it's the converse. Good. It's the converse because the original goes from lines to angles, and this one's going from angles to lines. So we're using the converse of that one. Okay, what about the last one? What kind of angle pairs? Those are vertical, right? So do I have enough information to prove that the lines are parallel? No, I don't. So you would circle any I, and you would just say vertical angles are not sufficient. Okay? Guys picking up what I'm putting down? No? What's the problem? You, like I said before, it's the converse if you go from angles to lines. What we were learning before with solving was we had the lines were parallel first and then we solved using the angles. This one we're doing the backwards of that. We're starting with the angles and going to the lines. Alright, I'm going to have you guys do the second row by yourself. Okay. Second row by yourself, please. You guys still use the same trick as before if they don't have a relationship to begin with. Use the same trick that we learned with solving.
Perhaps you just solve for unable to do. Yeah, look at that.
relationship. This was an semester to solve for this. But no, she's got no lines of parallel. You can't use equal relationship with parallel lines and you don't know the parallel. See which number is she says 16. Is in a relationship with oh, I didn't. No. I mean, you can do that here. There's no parallel, but they're not parallel with no oh, wait. They don't have a relationship with ours.
Oh wait, then
don't know what I'm gonna be. We don't understand the particular part of watching during and then shall they like our exercises and it's so like you know she's getting like stuff and all will respect out and then she's like taking off she's like this little notebook and she's like trading it and doing things like wow she's like you have no idea what you're talking about.
Alright, everybody clamps back up, please. Who can give me the answer for the first one on the far left? Go ahead. Alternate exterior?
Sorry, alternate interior.
Yes, it's no, because alternate interior are not congruent. Everybody get that? What about the next one over? How do you approach that, Shaylee?
Because vertical angles are not sufficient.
Well, first of all, for vertical angles, you would not choose no.
Oh, yeah, sorry.
But they're also not vertical.
Oh, I see. Never mind.
Brody?
Yes, consecutive interior angles are congruent.
And how they don't look consecutive to me right now. Yes. Just like in the solving, if they're not in a relationship, but you can move them using vertical angles, do so. Once you move the 27 or you move the 153 out, doesn't really matter. Now you have consecutive relationship and they do add up to 180. So yes, because consecutive interior or exterior, depending on which way you do it, theorem commerce. Alright, next one over. Anybody for the one in the middle? Good.
No, because corresponding angles.
Good. So they know because corresponding angles are not congruent when they should be.
Yes. Because consecutive interior angles.
So you moved the 91 inside? Okay, so this is another one where they didn't have a relationship to start, so you use vertical angles to shift one, either out or in, depending on which way you want to go. So those do add up to 180, so yes, because of consecutive interior angle theorem concepts. Or exterior, depending on which way you go. And then what about our very last one?
Not enough information.
Okay, so this one would be NI, and why?
Linear pairs not sufficient.
Linear pair is not sufficient. Alright, so is everybody okay with the second row? Understanding?
Which one was the last one?
Last one should have been NEI because linear pairs are sufficient. Alright? Is everybody good with that? Alright. Take a look at the questions at the bottom of the page here. The directions say find the value of x that makes j parallel to k. Right? Notice that there are no parallel line symbols anywhere. Do you guys see that? I don't have the little arrows, right? Typically on day one, when I asked you guys to solve, I told you guys you cannot do that unless the lines are parallel. Right? But there are two different ways that they can tell you the lines are parallel. They could either put the little arrowhead on the lines to show you visually that they're parallel, or they can say in the directions that they want you to assume that they are. So this make j parallel to k thing is they're telling you go ahead and pretend that they're parallel to find x, right? Those are the only two ways that you guys are allowed to solve, is if they have the symbol in the picture or in the directions they tell you that they should be parallel, okay? So you're going to do exactly the same thing as you did before. Once you've confirmed that they're parallel by the picture or directions, figure out what type of angles they are, write the equations off. So what kind of angles are these? Corresponding, they should be equal or congruent, so you're going to write an equation. Set them equal to each other. Solve, you should get x equals, let's see, 29. Okay, so algebra, you guys should hopefully get 29. Yes? Right, what kind of angles are these? These are the parallel ones, and this is the transversal. They're alternate exterior. They're outside of the two lines, and they're on different sides of transversal. Alternate exterior. What should be true about their measures? So write an equation. First person to find x, go ahead and try it out. 6. Alright, the one on the far right is a little bit more complicated because there are 4 lines. So my recommendation for you guys, whenever you guys are solving, whether it's a simple diagram or complicated, listen please, I want you guys to highlight the lines that are supposed to be parallel, whether they give you the little symbol or they tell you in the directions. Then you guys need to isolate which is the appropriate transversal to use. Is it going to be the one on the left here or the one on the right?
Left.
We have the left one that's more vertical and we have the right one that's more slanted. You're going to want this one. That's starting on the left versus starting on the right. Alright. If it's helpful, you guys can actually redraw the picture underneath. If that isolates the information for you, you can redraw it. It might look a little bit neater. What kind of angles are those?
Consecutive exterior.
Consecutive exterior. What should be true about their measures? They should add to 180. What's the value of x?
Oh, you put nice.
Nine.
Wait.
Usually 180, and then I got that 135 minus 180 minus 135, 45, 5x.
Right, is everybody okay with this?
No, no.
This is just review from day 1. I'm just explaining the difference in the directions this time. We can do it the same way. All right. Take a look at the next page. Read the directions very carefully, everyone. On the next page, it says solve for x, then determine if the lines are parallel. So, what do I know about the lines so far? Do I know if the lines are parallel? Do I have the symbols? Do I have the little symbols in the picture? Do I have the little statement in the directions where you can assume that they're parallel? No. So we know that the lines cannot be parallel by assumption. The lines cannot be parallel by assumption. So here's a follow-up question. If I can't assume that the lines are parallel based on the directions or the symbol in the picture, am I allowed to use corresponding angles to solve? Do they still have a relationship if the lines are not parallel? Can I use alternate angles? Can I use consecutive? What types of angles can I use? Vertical and linear pair. We can use those to solve. We can use them to solve. We cannot use them to prove that lines are parallel, but we can still use them to solve. So in this kind of situation, it's very important you guys know the difference between this and the ones we just did. We do not know if the lines are parallel to begin with, so we cannot use corresponding, alternate, or consecutive. I know you guys are going to be tempted. You're going to see this and you're going to want to do x plus 20 equals 2x minus 30. But can you? No, you cannot, because you have no idea if lines are parallel. So that relationship does not exist right now. So how would I solve for x? What's another angle relationship that's safe, regardless of whether the lines are parallel or not? Vertical. He's right here. So you're going to do 74 equals 2x minus 30. You can use this in any. You can use this relationship whether the lines are parallel or not, but you have to use it if you for sure know that the lines are not parallel to begin with. By assumption, you can't not assume that they're parallel. So if I add that over, I'll get. So what is that? What? Say again? 52. 52. All right. So that's half the questions answered. I can move this. Sorry, that's not supposed to be there. All right, the rest of the question is asking, are the lines indeed parallel? So now that I have x, how can I verify if the lines are parallel? Yes, Bertie? Okay, so if I plug it in here, this would be 72, right?
Yes.
What would this angle be?
74.
So, would the lines be parallel? No.
I'm parallel.
So you treat this question, the second half of the question, you treat the second half of the question just like we did in the chart on the first page. You figure out what the angles are, and then you figure out whether the relationship is working the way it's supposed to. So this one's no, because the corresponding angles are not congruent. So basically it takes the solving question in the first part of the lesson and mushes them together. All right, here's another one. How can I solve for x? Your instincts are going to tell you, take 69 and set it equal to 3x. But can you do that in this situation? No, because you do not know if the lines are parallel. Yes?
If the vertical of 5 minus 4, then you consecutive.
What? Put this here and do consecutive? No, you still can't use consecutive if the lines are not parallel. Because the consecutive angles are only supplementary if the lines are parallel, and you don't know that they are. Kaylee?
Use linear pair.
There you go. Linear pair. That is valid regardless of whether the lines are parallel or not, so we're going to fall back on that. So for linear pair, I'm going to have 5x minus 4 plus 3x equals 180. Doesn't help you out? What's 184 divided by 8?
23.
Okay.
23.
Does everybody understand why x is 23? Now that I know what x is, how do I verify if lines are parallel? Daniel?
Plug into the 3x.
Okay, so what do I get?
The 16.
So if that's what the angle is based on x, can I conclude that the lines are parallel?
Yes.
Based on what?
The
Alternate, interior, angles. Oops.
Yes.
Well, okay. Theorem, is it just the theorem? It's the converse. Alright, everybody stop talking, please. I want to reiterate something one more time. If you do not have the parallel symbols or the statement in the directions allowing you to force or make the lines parallel while you're solving, you cannot use corresponding, alternate, or consecutive angles, because those only work when the lines are parallel. What are the only angle relationships you can use? Vertical or linear pair. Right? Very important. You guys have to read the directions very carefully in this chapter in particular, for this unit. Okay? Everybody okay with that? Alright. I'm going to briefly talk about this. This is not really anything new. You guys know this. I'm just going to state it and visually show you. If a transversal is perpendicular to two lines if and only if they're parallel to each other. So this is something you guys already know. It's basically saying that if this line is perpendicular to those two, they ought to be parallel. And why would you know that? Because corresponding angles are congruent. You guys already know that. Right? They're both 90. Corresponding angles are congruent. That's why they're parallel, blah, blah, blah. Okay. Alright, what about these ones? This one says if A is parallel to B and B is parallel to C, then by the transitive or substitution property, A is parallel to C. This is when you guys have three lines. So I can go from here to here, and then here to here. I can also conclude that the first and last are parallel. By transitive, it's just like syllogism. P to Q, Q to R, therefore P to R. Just like the syllogism, you can use transitive for parallel as well. Okay? So, can anybody tell me why A and C would be parallel? Just those two. Because alternate interior, because of the alternate interior angle theorem converse. A lot of words there. I know. Why would C and B, just the last two, be parallel? Say again? Which one? They're consecutive interior.
Oh yeah, that's
Consecutive interior angle theorem converse. So I can prove that A is parallel to C, and I can prove that C is parallel to B, but is there a transversal that goes straight from A to B? No, so I have no way of proving that A is parallel to B using angles, but I can still say that A is parallel to B. Why? Which property would you say, like if you saw this in the proof, what property would you say? The transitive or substitution. I don't care which. Transitive or substitution. I know, that's in general. I changed the letters in the picture. I don't know. It's fine. Line 1 to line 2, line 2 to line 3, gives you line 1 to line 3.
Okay, so trans.
Alright, so everybody okay with those? They're just two new ideas that you guys have probably seen before, just presented differently. Alright. Quiet, please. Dante, and over there. Stop talking, please. Alright, this next set of questions I'm going to ask you which lines are parallel based on the given angles. Everybody keeps leaving. Alright, which lines will be parallel if 6 is congruent to 7? Yeah. Which one? Alright, does everybody agree? How would you know?
Because they're alternate interior.
Okay, so 6 and 7 are alternate interior using this transversal. And the two lines that you're crossing with the transversal are M and N. So those are the parallel ones. It's a pretty straightforward method, you guys. Whatever two angles you're working with, find out what the transversal is. Whatever other two lines are crossing, those are the ones that are parallel. Pretty straightforward. So what about 4 and 7? I'm afraid to erase. I mess up everything. Well, okay, that's fine. That was supposed to be erased, but not working. Alright, so 4 and 7. Alright, here. What's the transversal that they are both resting on? M.
And B.
What two lines did I just cross with my transversal? So those are the parallel ones.
I'm so confused. I don't know.
Because 4 lies are
Alright, what about if you guys are looking at 7 and 9? What transversal are 7 and 9 on? M. So what two lines does M cross?
A and B.
So those are the parallel ones.
Sorry.
What about 6 and 5? What transversal is 6 and 5 resting on? A. What two lines does A cross? N and M. So those are the parallel ones. So those are pretty simple questions. You guys need to figure out what the transversal is. Whatever two lines are crossing with the transversal, those are the parallel ones. Alright? Unless I'm going to do something like this. Everybody watch. It's not in the notes, but I'm going to verbally explain this question. What if I said 6 is congruent to 4? Which lines are parallel? 6 is congruent to 4. Which lines are parallel?
No.
6 is congruent to 4. Which lines are parallel?
Can you see?
A and B. I don't know. I said
A and B are parallel.
No, wait, you hear the right answer.
A is parallel to M.
Nope. Well, apparently they're not because they're intersecting. 6 is congruent to 4. Which lines are parallel? Alex? So what would you say? You would either say any I or none. Because you don't know enough information to say that the lines are parallel. They're not even on the same transversal. So you would say none of I don't know any of them are parallel. So either you would say not enough information to determine the answer or just say none. So make sure you're looking out for those. Alright. My favorite diagrams. Actually, these are my favorite. The ones on the other page are my favorite. I have two different kinds of diagrams that have lots of lines in them. Right, this one I like to call the hashtag. Right, when you have at least 4 lines, you can have more than that, but if you have at least 4 that are crisscrossing to make that hashtag kind of shape or tic-tac-toe board. We have a special strategy that we use. Because the question they're going to ask you is, in this picture, which lines, if any, must be parallel? And we're going to be using the angles to help us figure that out. So, the way that we do that is you're going to pick, Evan, help me. If I try to do all this writing and messes it up, I'm sorry. Pick a transversal with 2 angles on it. Alright, that's your first step. Pick a transversal and make sure that has 2 angles on it. Let's do. Check for valid angle relationships. To determine parallel lines. And actually managed to write all that. Yeah. So your strategy is pick a transversal in your picture that has 2 angles on it. Then you're going to check to see if those 2 angles you're working with have a valid angle relationship, which will help you determine if the lines are parallel or not. So take a look at this one. I have A, B, C, D, and E. There's 5 different lines in here. Can somebody name a transversal for me that has 2 angles on it? Whether they're labeled with numbers or just congruency marks. Birdie? Do you see a transversal that has 2 angles on it? A. For A, we're going to be looking at these 2 angles right here. We're going to ignore the 75 because that's not in a relationship with any of the other angles. So I have those 2 angles right there. What kind of angles would I call those? Corresponding. Now, what's supposed to be true with corresponding angles? Are they congruent based on the markings? Yes. So that forces which 2 lines to be congruent? C and D, the 2 lines that you use to create those angles. Do you guys see? We create these 2 angles between the transversal and C and the transversal and D. So I know that C and D are parallel. Okay? Okay, well, hold on. There could be more than one. Okay? It says which lines, if any. So there could be none, there could be 1, there could be 2, there could be multiples. Okay? There's not always just one answer. Okay. I'm sorry, I cannot change colors. Oh, wait. Maybe. Nope, can't change colors. All right. What's another transversal that has 2 angles on it? Say again?
B.
B. All right. So I have these double mark angles. What kind of angles are those? They are corresponding again. And what's going on with their measures? Are corresponding angles supposed to be congruent? Okay, so which 2 lines would be parallel? Very good. Just based on this, let's pause for a second. James, just based on the fact that C is parallel to D and D is parallel to E, C is parallel to E. That's the transitive property. That's transversal abbreviation. Well, but that can be transversal or transitive. So I tried to add a little bit more. So that's a transitive property. Right, because there's no transversal that goes directly from C to E with angles. You have to use the transitive property to figure that out. All right, there is one more. Transversal has 2 angles on it. Yes? What's the other transversal with 2 angles?
D.
D? Okay, so what kind of angles are those? They don't currently have a relationship. But if you move it here, they're consecutive interior. But I don't know what their measures are, guys. I don't know what their measures are. So can I conclude that they're supplementary? No. So you can't use that transversal. Try another one. Okay, we have this one right here. That's a 75 and a 100. They are consecutive exterior, which should be 100 plus 75, 180. So would these 2 be parallel? No. So this is it. This is it. You try all of your different transversals that have 2 angles on them until you've exhausted all your options, and then you stop. So it's those 3. Right? Here's our true hashtag right here. Let's try another one before we go on to fences. Fences are no good. All right. Why is the transversal has 2 angles on it?
B.
B. Okay, cool. Do those angles currently have a relationship?
No.
How can I fix that?
Move the 10 vertically.
Okay, move the 10.
Then you hit consecutive things.
Those are consecutive exterior, which should be.
Supplementary.
Are they? Are they?
Yes.
Okay, so then what lines would be parallel if we have a valid relationship?
C, W, D.
C and D, the 2 lines that your transversal is crossing. So C is parallel to D. Alright, what's another transversal that has 2 angles? C.
Yeah.
Okay, does the 20 and the 170 have a relationship right now? Can we fix that? Move the 20. Those are now consecutive exterior. What should be true about consecutive exterior angles? Do they equal 180?
No.
So then would A and B be parallel? No. So our answer is just C is parallel to D. So that's how you guys approach hashtag questions.
Is that all we do?
Yep. You just, until you can't find any more transversals, you just,
Paragraph is saying like.
So when they ask you to explain your reasoning, you would just really. I just want to verbally saying it. So you would typically tell me the angle relationship. No,
Okay.
I was there. Too far. Okay, fences. Alright, everybody listen up, please. Fences are my favorite kind of diagram. I call them fences because you guys have a bunch of like vertical or horizontal pieces and then just one kind of going through. So if you like turn on its side, it kind of looks like a fence. So, yes.
If that's the case, then I don't recommend that.
Oh, yes. I wouldn't recommend that person to fence your yard either. So for fences, it's a very straightforward process. Please don't be right. Okay. Pick one side of the transversal because you're only going to have one transversal. You should only have one transversal in the picture, so you're going to pick your favorite side. Pick one side of the transversal. Find all. Oops. Sorry, that says find all the angle measures. And then third step, look for corresponding angles. Pick one side of the transversal, your favorite. I'll explain what that means. And the part that's all bubbled out here. Find all, it won't. Find all these angle measures and then look for corresponding angles. Yep, that's an abbreviation, CORR.
How is this projection on a whiteboard?
It's interactive, it just doesn't work. Alright. So this is what I mean. You guys are going to pick your favorite side of the transversal. So in this example, which do you think would be the better side?
The left side.
The right side, which has all the information on it. Okay? You guys are going to find all the angle measures using only vertical or linear pairs. Go ahead and write that down, please. You're going to find find, you're going to fill in all the angles that are missing using either vertical or linear pairs, depending on what situation you're working with. And then once you have all the angles filled out, you're just going to look for any corresponding angles that match. So for example, if I know this angle is 110, what would this one that's empty be? 70. Good. This one's 110. What would this empty one be?
110.
No. This one, linear pair, 70.
All linear pair.
Yes. We don't know if lines are parallel right now, guys. The directions do not say that they're parallel, and we don't have a parallel symbol, so you cannot use any of the angle relationships from parallel lines.
Are we only doing the supplemental?
Exactly. That's why you just pick one side.
Oh.
One side. All right. We have another 70 right here, and another 110 right here. Just fill it out. You guys know how to do that. Now, your next mission is just take a look and find any corresponding angles that are congruent, and that will make the lines parallel. So you guys see any?
110.
Which two?
The top and top. No, top and
They are lettered.
top and second.
They are lettered. Okay. So A and B are parallel because I am trying to avoid writing because it tends to mess up the board, but you guys would give me a quick explanation. You just say corresponding angles are congruent, right? Or you can state the converse of the theorem. So I know that A and B are parallel. What else? Do you guys see any other corresponding angles?
B and C. No, sorry.
B and D. You see B and D have the top right corner are 110. So B would be parallel to D. Is there another set? A and D. So all those are parallel because the corresponding angles are congruent. Yeah, C is just random and they're not really doing anything. Yeah. Right? So that's basically how you guys work with fences. Just look for corresponding angles. Right. This one is more. Yes. This one's more your choice. Would you guys rather fill in the top or the bottom? The top? Okay. So this is where you guys want to bring vertical angles into the picture. So that's going to shift everything on the bottom up to the top. So if I know this is 99, we have a 99 right here as well. Okay? What's the angle next to that using linear pair? 81? No. No. Isn't that 81? No, it's not 81. What am I talking about?
88.
80. It is 81. Yeah, because you have to get it to 180. 180 minus 99. 80. Does everybody understand how I got those two? Vertical and then linear? Alright, how do I find this angle next to the 82?
180 minus 82.
Okay, so that's
98.
good. How do I pull the 96 to the top? Vertical, so I get 96. What's the one next to it?
84.
And then what's the missing angle next to 98?
82.
Alright, so now I have the entire top of the transversal written out. So now I just look for the corresponding angles.
C and E.
C and E, I see 82 and the 98 match up. So C is parallel to E. You guys see any others?
Nope.
So that's it. Alright. So you guys could have multiple answers. You guys could just have one, or you could actually have 0. You could have no lines in parallel. So make sure you're looking out for those two. Questions on fences? We're almost done.
Fine.
Alright. Alright, this is our last section, guys. Listen up. Alright. Determine the truth of the statement. I put this in here because this is what your quiz is going to look like. Okay, so pay attention. Determine the truth of the statement based on the diagram and explain. So you guys are going to be referencing theorems for this one. So my first statement The first statement says that angle 1 plus angle 9 being equal to 180 implies that n is parallel to m. Is this true or false? If you look at angle 1 and angle 9, what kind of angles are those? They're consecutive exterior, which should be equal to 180. So this is a true statement, but does it prove that these two lines in particular are parallel?
No.
Yes, it does. Okay, so this would be true. And why would you explain? What would you give as the reason why? You're going to reference a theorem for me. Or a convex.
Exterior angle. Exterior.
Yes. Consecutive exterior. Yes, include the converse. Just like we were proving stuff on the very first page. Right, angle 1 being congruent to angle 4 implies that B is parallel to A. False. False? Why? Because they're vertical. So you would say false because vertical angles are not sufficient, just like we were doing in the front. All right, 6 and 7 being congruent implies that A is parallel to B. I have 6 and 7. What lines do they actually prove to be parallel? So they chose the wrong lines. So this one would be false, and you would just say wrong lines. That's not necessarily a theorem. They didn't get the theorem wrong, they just chose the incorrect lines for the application. Does everybody understand why it's not A and B? You can't have A be one of the parallel lines if it's the transverse. Okay? What about 2 plus 4 being supplementary, implying that n is parallel to m? Why? Yes. 2 and 4 make a linear pair, and that's not sufficient to prove parallel. So you'd say false. Linear pair is not sufficient. Oops. Oh no. Stop. Okay. Not. Alright, what about this last one? 7 being congruent to 9 implies that the A is parallel to B. Why would that be true? Consecutive. Alternate exterior. Yes. I'm going to try just because I wrote. Alternate exterior, right? Theorem. Yes?
Yes.
Alright. Sorry, that was a little long. It's all the writing. Say again? Theorem converse? Because you're establishing the ground for proof. These are basically one-step proofs that you're giving me. No, 5 minutes left.